All right, so for the next one, the student asked me to do something on long division. And I basically just wanted to make up an answer. And typically in my class, when we're doing long division, we're finding zeros of polynomials. We're not just doing division to do division like we did in Algebra 2. So I'm just going to kind of work through a typical problem. And I hope that these are zeros. Otherwise, I'm just going to kind of change the name of the problem. But if these are zeros, then we can write them as factors. So that would be x plus 1 times x minus 1. And then we could multiply them to give us another factor of x squared minus 1. Now, the reason why you could do synthetic division in this problem, and again, whenever you're doing synthetic division, you have to have linear factors, which in this case we do, but we have to do synthetic division twice. So a lot of times it's better what I students is if you have a quadratic factor is just to go ahead and use long division. So in this case, I have x squared minus 1. And therefore, you're going to take your polynomial, and we're going to write it under here. Okay, and now we're going to go ahead and do our long division algorithm. So long division algorithm basically says is take this first term, x squared, and you're going to divide it into the first term of your dividend. So x squared divides into x to the fourth. If that is confusing, I always told my students to write it to the side. How many times is x squared divided into x to the fourth? Well, that is x squared times x squared, and then you're going to multiply this times both terms. So x squared times x squared is x to the fourth. X squared times negative 1 is a negative x squared. Well, I don't want to put that under an x cubed because those aren't like terms, right? So I'm going to put it under this x squared. Then we're going to group the first two terms and subtract them. So I have nothing to subtract a negative 3x squared from. You could use a placeholder of a 0x cubed if you like. But now let's go and subtract the rows. Again, if you're doing this correctly, your first two terms are always going to subtract to 0. But then I have a negative 3x minus 0, negative 3x cubed, minus 0. That's going to give you a positive 2x squared. And then you could subtract everything if you want to. Again, you could just write this as a 0x plus 0. And therefore, you'd have everything down. A lot of times, just to save ourselves the time and the space, we don't bring everything down. We just kind of leave it until we need it. So now x squared divides into a negative 3x cubed. Again, write this to the side. Negative 3x cubed divided by x squared. Well, that's going to be a negative 3x. And now I'm going to multiply that times both of those terms. So negative 3x times x squared is a negative 3x cubed, which is the same. And negative 3x times negative 1 is going to be a positive 3x. So again, I'm going to write those down, group and subtract. Here, I'm not going to write my placeholders. So therefore, negative 3x cubed minus a negative 3x squared, that's going to go to 0. Then here, I can just bring this down to a 2x squared. That's going to go to 0. And then I'll have a minus 2. X squared divided into 2x squared. Positive 2 times 2x squared. And then 2 times negative 1 is a negative 2. And you subtract. And I did do my work right. And therefore, you have a remainder of 0. So, and again, the important thing in the concept in what we're talking about, if these are factors based on the zeros, well, since x squared minus 1 divides into this, x squared minus 3x plus 2 times, then that is also a factor. 3x plus 2. And I could factor that down one more time to give me a x minus 2 times a x minus 1. So therefore, we could say the linear factorization, something that we would do in this class, we would say is going to be x minus 2 times x minus 1, which occurs twice, so it has a multiplicity of 2, times an x plus, that looks really bad, times an x plus 1. So the student asked me to do something on long division, but so there's the work on long division, but I just want to kind of add in something from polynomials that we do at least